the edge of the Chihuahuan Desert in southeastern New Mexico, there's a cave system so vast it doesn't feel like a cave anymore. It feels like an underground world with its own rules, Carlsbad Caverns. And if you visit at the right time of year, you'll see the moment that makes the title feel literal, a bat storm. Thousands of bats pour out of the natural entrance at dusk, spiraling into the sky in a living column, as if the darkness itself is leaving the cave to hunt. Carlsbad Caverns sits in the Guadalupe Mountains, inside thick limestone that looks permanent until chemistry proves otherwise. What makes this place unsettling is scale. Chambers big enough to swallow buildings, passages that stretch beyond what a flashlight can fully claim, formations that look like frozen motion. And yet the cave isn't dead space. It's structured, active, and inhabited, just not in the way most people imagine when they hear the word cave. The first surprise is the bats. Because they aren't a myth or a rare sight here, they can be a seasonal presence so large you feel it before you understand it. Their emergence isn't random. It's timed to light and temperature, a daily launch that lets them feed on night-flying insects across the desert. The second surprise is that the cave life doesn't begin with bats at all. It begins with scarcity. In darkness, plants can't grow, so the entire food web depends on what drifts in: insects carried by air, organic debris washed by water, and most importantly, guano. Bat guano becomes an energy source that supports bacteria, fungi, insects, and predators that feed on the creatures drawn to it. The geology is the part most people get wrong, and it changes how the cave feels. Many caves form when rainwater becomes slightly acidic and slowly dissolves limestone from above. Carlsbad is famous for a different mechanism. Water and gases rising from deeper sources can create aggressive chemistry underground, dissolving rock from within. Over time, that process can open large voids and create a cavern system on a scale that seems engineered. Later, as the cave becomes ventilated and water drips through it, the decorations begin. Stalactites, stalagmites, draperies, mineral deposits built from droplets that leave tiny rings of calcite behind, one layer at a time. Then there's the chamber people remember, a space so enormous it breaks your sense of proportion. In rooms like this, darkness isn't just the absence of light, it becomes distance. Your eyes can't measure edges properly. Sound behaves differently, stretching and fading as if the cave has more space than it should. And in the middle of that, the living layer continues. Insects that thrive around guano, spiders and beetles that hunt them, crickets that move between zones, microbes that quietly colonize damp walls. It's not a jungle, it's an economy built on limited fuel, where life survives by being efficient. Here's the question that should reset the way you picture what lives down here. If food is scarce and light doesn't exist, what does it take for an animal to survive in a giant cave long term? The answer is adaptation. Many cave-dwelling species reduce anything they don't need: pigment, strong eyesight, even energy-hungry behaviors. Because in darkness, wasting energy is a mistake. Some creatures live near entrances where resources are more available. Others specialize in deeper zones where conditions are stable, but food is rare. And the cave itself holds steady temperature and humidity compared to the surface, which is why it can feel strangely constant. Like time slows the deeper you go. The bat storm, though, is still the scene that turns this place from geology into something primal. As dusk arrives, bats begin to circle inside the entrance, and then spill out in waves, forming a tight spiral that helps them avoid predators and organize into flight paths. For a few minutes, the sky above the entrance becomes crowded with movement, while the cave behind them becomes quieter, temporarily emptied of its most visible residents. It's a reminder that the cave isn't just a destination. It's a shelter, a nursery, and a launch point. The ecosystem here isn't contained underground. It connects directly to the desert outside through nightly migration. And there's another kind of life that makes this place feel eerie: microbial life. In caves, microbes can form thin films on rock surfaces and contribute to mineral changes over time. They can also preserve clues, chemical signatures that help scientists understand how caves evolve and what conditions were like in the past. Add to that the formations themselves, mineral layers that can act like slow record keepers, storing information about rainfall, climate shifts, and water chemistry over long timescales. So, what lives in this cave includes not only animals you can see, but entire microscopic communities, and the evidence of ancient environments trapped in stone. Impact on modern life shows up in 3 ways at once: conservation, science, and scale of human attention. Carlsbad Caverns is a major protected site, which means managing tourism without damaging fragile formations or disrupting wildlife, especially seasonal bat behavior. It's also a research environment that helps scientists study cave formation, mineral deposition, and environmental history recorded in speleothems. And culturally, it changes how people think about subterranean spaces. Caves stop being holes and become complex systems tied to surface ecosystems, climate signals, and biodiversity that depends on darkness to survive. If this place made you rethink what alive means in the dark, like this video and subscribe to Off the Map. And don't leave yet, because the next episode takes you from black limestone chambers to a lake so intensely blue it looks edited. Next, Crater Lake, Oregon. Why is this lake so blue? When you see that color sitting perfectly still inside a volcanic rim, you'll realize the strangest places aren't always hidden underground. Sometimes they're staring back at the sky.